Hello and welcome back to Technical Tuesdays. This is the series where we explore how different parameters within injection moulding can have an effect on the final part or product. In this episode, we're going to explore the importance of clamping force and how increasing it and decreasing it will change the final part. So, first things first, what is clamping force? To give an accurate answer to this question, we must first understand where in the injection moulding process clamping force is used. Once your material has been fed into the barrel and heated into a liquid, the moving half of the mould tool will close. This action uses clamping force to hold the moving half firmly against the fixed half to create a tight seal. Having enough clamping pressure is absolutely vital, as it counteracts the forces of injection and packing pressures and prevents any material from leaking from the parting line. The example we're going to use in this episode is the front case for a 2-pole voltage tester, more specifically the T110 from Fluke. Multiple components go into moulding the T110 case. We have the window and buttons, as well as the probe for the top of the case. The window and buttons are made from a single shot process, using polycarbonate with a UV stabilised, mould release and flame retardant additives. The probe is made with a method called Insert Moulding. This is where a prefabricated part, such as the metal insert, is placed into the mould tool so that the polymer can be injected over the top. To create the entire front case, both the clear windows and buttons and the probe are inserted into the mould to allow for the PC ABS blend with flame and heat resistant additives to be injected over the top. Clamping force is the force applied from the moving half of the tool against the fixed half. It's usually measured in tons or kilonewtons. The maximum clamping force of our Arberg All-Rounder 630S is 275 tons. This may seem like a lot of pressure just to inject liquid plastic into a mould, but when you consider the force with which the plastic is injected and how tightly the mould must be sealed, 275 tons isn't actually that much. When using materials such as TPE, you need a higher clamping force. This is because when the TPE is injected into the mould, it's not a viscous liquid, meaning that the material finds it easier to escape from the parting line. You can reduce the necessary clamping force when using materials such as nylon. This is because nylon is a viscous liquid and will therefore have a harder time leaking from the parting line. There are of course lots of parameters that will determine the correct clamping force to use. Material is just one of these parameters. When we reduce the clamping pressure on the front case by only 25 tons or 255 kilonewtons, you can see there isn't enough force to seal the mould tool and you end up with flashing on the parting line. Any flashing around the edge renders the part unusable, as the extra material means that the front and back casing won't fit together. It is also possible that if you haven't got the clamping force correctly set, that you may not be able to see any difference, but the weight in the part could be under tolerance, resulting in a product failure. This is harder to detect, so you could potentially make thousands of scrap mouldings without knowing until it's too late. When we increase the clamping pressure, you can see it doesn't have any effect on the part. However, it could give you gassing issues, as it could prevent the tool from naturally venting, resulting in burning. Providing your tool has good venting, as it does with this example, using too much clamping force will just use more energy. Whilst this won't affect the part price for your customer, the extra energy used will contribute to higher energy bills and an increase in pollution being released into the atmosphere. The increased pressure will also influence your machine's lifespan, as it's unnecessarily working the machine harder than it needs to. So that wraps it up for this episode of Technical Tuesdays. As always, we hope you guys learned something. If you have any comments, suggestions or questions, please leave them down below. Other than that, we'll see you all in the next episode.